Good morning. Today we're going to be talking about double replacement reactions. And in this double replacement reaction, what we're going to be doing is question 35 from the book. An aqueous solution of aluminum chloride, and sodium hydroxide are mixed, forming a precipitate aluminum hydroxide. So we're going to look at aluminum chloride and allow it to react with sodium hydroxide. This is a double replacement reaction, and I'm going to begin with the complete equation. The complete chemical equation. And the first substance that was given was aluminum chloride. When I look at aluminum on the periodic table, it turns out that aluminum is in column 3A. Because it's in column 3A, aluminum is a 3+ ion. And aluminum chloride is in column 7A, so it's a 1- ion. So if aluminum and chlorine come together, it's got to be AlCl3, because there's one Al at a 3+, and it's going to require 3 Cl's at a 1- each. After the substance, we want to put whether it's soluble or insoluble. So here is aluminum, here is chloride, and it's SOL. That means it's soluble. Because it's soluble, it is going to form an aqueous solution. Aluminum chloride, and it says it's going to react with sodium hydroxide. Sodium is in column 1A, and it's a 1+. Hydroxide is a tricky element, and the reason that it's a tricky element, and actually it's not an element, I apologize for calling it an element, the reason it's a tricky substance is hydroxide ends in IDE, which makes you think it is from the periodic table because of fluoride, oxide, sulfide. Any of the elements that are in their ion form, the ending of their name gets changed to IDE. So when we have hydroxide, it makes us think that it came from the periodic table. But it's one of those tricky ones that ends in IDE, but it's on the polyatomic ion chart, hydroxide OH with a 1-. So it looks like the OH is a 1- also. So sodium hydroxide, sodium as an Na with a 1+ because it's in column 1A, and then hydroxide with a 1- just becomes NaOH. We're always putting these substances together so that the charges will cancel out. Now, we're going to have a double replacement reaction here. So that means that this first substance that's a positive is going to go with the second substance that's a negative, and this third substance that's a positive is going to go with this second substance that's a negative. Double replacement reaction. It doesn't necessarily matter which one you write first. So I'm going to take the Al, which is a 3+. I'm going to take the OH, which is a 1-, and it looks like I'm going to need 3 of the OHs to match the Al. The way that we have to write that, whoops, I already put down the line. The way that we have to write that is we have to write Al, and then in parentheses we have to put the OH because it's a polyatomic ion, and anytime you have more than one polyatomic ion, you have to put it in parentheses. So 3 1- and 1 3+. So then we look at the AlOH3 on our chart. So AlOH3 on our chart, Al and OH is insoluble. Because it's insoluble, that means it's going to form a solid precipitate. This is not going to break apart in water, and that's what the question stated, the precipitate aluminum hydroxide. The term precipitate means that it is a solid and it will not dissolve in water. The other thing that I realized is I forgot to check NaOH. So I go over to Na and I find OH, and it is soluble. Since NaOH is soluble, we would put AQ on the end. So we know this reaction is going to happen. One of the indicators for a double replacement reaction is it's going to happen if one of the products is a solid precipitate. So let's go ahead and finish the reaction. We're going to write Na first because it's the positive, and the positive always is written first. And then Cl with the 1 minus. So this just becomes NaCl. And we've seen NaCl placed into water, and we know that Na and Cl is going to be soluble, so it's an aqueous solution. This is the complete chemical equation. Now what I would like to write is I would like to write the complete ionic equation. And when I look at the book, technically this is just called, this top equation is just simply called the the chemical equation. They don't use the word complete chemical equation. So I want to make sure I'm using the same terminology. So this is just the chemical equation. This is the complete ionic equation. The complete ionic equation shows all of these substances as they exist in the reaction. What that means is if it says AQ on the end, which means it was soluble, then that means it really isn't as this substance indicates. It is separated into its individual ions in solution. So I'm going to separate the Al3 plus from the Cl1 minus, and they are both in aqueous. But here's something I want to point out that's very important. This one substance, when it separates into one Al3 plus and 3 separate Cl minuses. So when I write the equation, I need to put a 3 in front of here for every one of those. This also reminds me, and there's been a couple things that I've made mistakes on as I've gone through, that I forgot to balance the original equation. There's 3 OHs over here, so I need to put a 3 here. That gives me 3 NAs, so I need to put a 3 here. That gives me 3 CLs, so I need 3 CLs and 1 AL. Everything else matches. So this did not change because I didn't have to change a coefficient. Then the next thing is I need 3 NAs, 3 Na pluses, and I need 3 OH minuses. I'm separating these because they are in an aqueous solution. And the complete ionic equation demonstrates the substances as they are in the solution. So I need to separate them. And there's 3 Na pluses and 3 OH minuses. We have to be careful. When we get to the next substance, we do not separate it. It is a solid precipitate. So it would be incorrect to write this separated. AlOH3 is a solid precipitate, so we write it as a solid precipitate. And then once again, I don't have enough room on just like my previous example, so I'll just put it underneath. I get 3 Na pluses that are in the aqueous solution and 3 Cl minuses that are also in the aqueous solution. So if you were looking at a beaker of water, when you took a solution of AlCl3 and poured it in, and you took a solution of NaOH and poured it in, really what you would be getting is a solution with Al3 pluses floating around, 3 Cl minuses, a ratio of 3 Cl minuses, probably 3 billion to 1 billion. Na pluses floating around, also a ratio of 3 of them. And then OH minuses floating around, and I've drawn them all kind of grouped together, but obviously they would be free to float around wherever they want. And then the one precipitate, there would be a precipitate, a solid precipitate forming down on the bottom. That would be AlOH3 solid precipitate, but everything else floats around as an ion form. So I want you to notice something. First off, Al3 plus starts as Al3 plus and forms a solid precipitate. It changes. But the 3 Cl minuses start as 3 Cl minuses and end exactly the same. They don't change. They start as 3 Cl minuses, they end as 3 Cl minuses. The OH minus changes because it started as an ion and now it's part of a solid precipitate. And the Na pluses do not change either. The 3 Na pluses do not change either. These that do not change, that are in this box, are called spectator ions. They spectate. They don't do anything. They just sit there and watch what's happening. They've never changed. So the final equation that we want to write is called the net ionic equation. The net ionic equation. And the net ionic equation only involves substances that changed. So it will not involve spectator ions. So it will involve Al3 plus, who started as an aqueous. It will involve the OH minus, which started as an aqueous. And those change into a solid precipitate. The water is trying to pull it apart, just like it pulled apart all these spectator ions, but it can't pull it apart. And the way we know it can't pull it apart is we use our chart, Al, and then OH, and it is insoluble. This is the net ionic equation. There are 3 equations that we need to be comfortable with. The first is a chemical equation, which shows all the neutral species, all the neutral substances together. The complete ionic equation, which shows them as they exist in the solution. And then the net ionic equation, which shows it as it shows what has changed during the chemical reaction. I hope this helps with chemical equations, complete ionic equations, and net ionic equations.